And you hear a lot of information about soils. Yeah, this is what I imagine, you dig down into the soil and we do a lot of soil pits. I would love to see a face down there one day. And he's happy, of course. Yeah. So people talk about soil health, but what does that actually mean? It sounds like it could be voodoo. It sounds like there's a lot of ambiguity, but science-based is really the ability of the soil to function. That's it. Your soils just have to be able to function. And it's like our bodies. We gauge our health by our body's ability to function. And with soils, they have 5 major functions, and that's to regulate water, letting the water infiltrate, and also being able to hold on to that water, providing nutrient cycling so that if there's carbon or residue in the soils, it actually breaks down into usable nutrients that the plants can use, provides physical support so we can stand on it, build on it, plants can root in it, support living organisms. So if you have a soil that nothing is living in it, no plants, no soil organisms, not functioning. It's actually technically not soil. Oh. Yeah. That's a big one. We'll hear more about that one later. And then filter and buffer. So with the different soil particles, organic matter, things like that in the soil, we're able to filter and buffer. So like our pH, if we put nutrients out there, to be able to balance that and not have it go directly, like right to the plant roots. It holds on to them. Yes. And doesn't give them that extreme shock of, oh, you put some nitrogen out there. Oh, yes, our soils will help us buffer that. So what happens when we disturb the soil? There's different kinds of disturbance. Mainly, I'm looking at the physical disturbance. If we use pesticides, fungicides, things like that, that's also a disturbance. But every time, we put a shovel on the ground, and I feel bad, I do a lot of soil testing. So I disturb a lot of ground. I put shovels in the ground all the time. But, try to minimize it. But every time we do that or till it, we're breaking apart these soil aggregates. And if you can see on this picture, it's a big chunk of soil, but there's a lot of small chunks on it. And I've got some examples up here that you guys can look at later too. When we're thinking about soil aggregates and soil structure, we want it to look kind of like cottage cheese. And then people say, oh, that's disgusting. Black cottage cheese. Yes, been in the fridge way too long. I know, but that's what we want, because that allows the air and water to get through there and the plant roots to get through really nicely too. So if we think about, we have plants growing in the soil, and those plants die off, the above ground stalk of it is directly linked to the roots. And so once they die off, they kind of act like straws going into our soil so that the water can infiltrate. And if we go and till or work up that soil, we're cutting off those straws and blocking it so that the water can't follow those pathways anymore. And actually, this is the biggest one that hurts me, is when we disturb our soils, we get a flush of oxygen into that soil and it releases and burns carbon, AKA our organic matter. And we know that that's like the most prized possession we can have in our soils is our organic matter, because that stuff is gold. Well, it's black, but it's gold, black gold, yes. We're cutting out those pores and channels. And because we're breaking the soil structure, we're losing those chunks, and it's able to compact on itself. And we're losing that strength and that ability for the soil to provide the support. And then we're reducing the water infiltration, and we're breaking the good fungi in the soil. Does anybody know what the largest living thing in the soil is? Yes, fungus among us. So my maiden name is actually mold. Yeah. Yep, where I come from, there's a bunch of us. So, it wasn't a weird thing until I moved out of the area, and it was like, oh, But, so I'm kind of impartial to mycorrhizal fungi and, some of those other critters out there, but they are so amazing for our plants. They connect up with plants and they provide it's like a super highway of nutrients, water, communications, very, very important for our plants. And then our plants don't have to expend so much energy rooting because it's just using its body to help shuttle that stuff for it. And then it causes the soil organisms to rebuild instead of benefiting the crops. So when I go and talk to kids about soils, I'm like, so what would happen? What would you do if a tornado came through your community? They said, oh, well, we would rebuild. We like our community. Yeah, great. That's great to hear. What if a tornado came through your community 3 to 4 times a year? What would you do? So we would move. I get it. And the same with those soil organisms, if we're constantly breaking up their communities, their homes, they're not gonna be able to survive. They're not gonna stay, they're not gonna flourish. And it increases the soil crusting and sealing because we're breaking those soil aggregates, we're compacting our soils. And that's what, if you see on the soil surface where it's really smooth, it looks like you can see like a little bit of sand particles sprinkled on the top and it starts cracking, that's soil crusting. And then the water has a really hard time infiltrating, and which, this winter we had all that snow and no frost, and so that moisture just went right into the ground. But now, I don't know about you guys, but in Chisago County, we haven't had any rain. I just looked at the drought monitor, we're not even listed yet, but I bet next week it might be different. Well, hopefully we get the rain on Tuesday and Wednesday. But yes, so all of these things, it reduces the ability for the soil to function and to be able to help our plants. And yes, that is a selfish way of looking at things. We always want to preserve nature and our natural resources, but we're utilizing our soils, to grow things. So if we can do those together to benefit both, I say, why not? So when we talk about soils, everything is so connected. It's really hard to talk about them linearly, but I'm going to try to start at the top and work my way down. So the raindrop impact, when raindrops hit the ground, they can hit the ground at up to 20 miles an hour. And so if you have bare soils with no protection, those raindrops are just punching the soil over and over again. If we can have something growing out there or some dead vegetation to help buffer that and take the energy out before it hits the soil, it'll help it so much, because when soils get saturated, they lose their strength. So after it rains, you go out there and you step down and it's squish, squish, squish. Oh, even in my yard, I tell the kids, during the rain and after the rain, stay off the yard. I don't even want to compact my yard. Yard isn't wonderful to begin with, so let's not make it worse. But yes, and so when our soils are bare, we've got this bare soil here, nothing to take that energy out, and those raindrops keep pummeling it. It actually breaks those soil organisms apart, and then they become single grain soils. And it's kind of like people. If we have our soils aggregated together, it's like a bunch of our buddies, we're all locked arms with each other. And if someone tries to come and push us, good luck. You're not going to move us. But if I'm all by myself, because the raindrop broke me apart from all my friends, it's going to be a lot easier to push me around. And so as we break those soil aggregates apart and we go into single grain soils, then they move with the water and they find any pores, channels, cracks, and it flows into them and it fills them up. And then the soil is sealed off and it can't infiltrate anymore. And then when it dries out, all those loose soil particles blow in the wind. Oh, I was working in southern Minnesota the last 12 years. And oh my gosh, the wind erosion down there, horrendous. Good thing we have trees up here. Man, I really missed trees when I was gone. So soil structure. So now we're getting in, look past the top. So why is it so important? Because that impacts our water infiltration and our movement. If we can't get that water to infiltrate, it's gonna stand on the top and it's gonna drown out our crops or provide pest and disease issues. And then later on, I usually say when the tap turns off in July and August, but now it's June, July and August. You know, we're not getting, if we weren't able to infiltrate that water from before, we're even drier now. We need that adequate pore space for that available oxygen and that water to come through. The biggest cause of disease issues for plants is because there's not enough oxygen in the soil. And it seems counterintuitive. Like, well, you know, we don't want too much oxygen in there, but actually only half the soil is supposed to be soil. The other half should be pore space for water and air to be able to take that space up. And it makes it easier for your roots to penetrate and move through the soil. If we've got that structure, and because of the oxygen availability, the water movement, it improves our nutrient cycling and our availability. If we have compacted soils, there's really no sites, there's no areas for the nutrients to latch onto and then be available for the soils or for the plants, and also the soil organisms to be able to get to them and make them plant available. And improves our trafficability. So if we have well-structured soils, we can walk on it, we can drive on it a lot sooner after rain events than if we just till the dickens out of it. And then soil organisms in life. If we keep coming through there with a tornado, you know, they're not going to be there. And they actually help build soil structure in a few different ways. It's really cool. Different glues, different exudates. So we need that soil structure to be able to have our soil function. So if I'm just gonna get nerdy just a little bit. I used to map soils in Pine County, which that county is still not done being mapped. It's the last county in the state. It's so frustrating, but it's gonna happen. But to nerd out, there's different kinds of soil structure, and that cottage cheese, that's that granular, and you'll find that up at the top, you know. And if you're out looking, and if you have bare ground, it's really hard to find that granular structure. But if you have some like residue, some old dead plants laying there, gently brush it aside. I bet you'll find that granular structure there. What's the difference? Because that soil is covered, is having that protection. Plus the soil organisms, they're like us. They don't want to come out when it's 90 degrees, and bare soils warm up so quickly and they cool off quickly. So those soil organisms are going to come up under the residue because it's nice and cool, it's protected. Plus there's food for them too. And then we get, as you get a little, I hit the wrong button. As we get a little bit deeper, we get blocky. So that small granular structure just gets a little bit bigger, and that's okay. What we don't want to have is single grain. That's where it's like salt. And we don't want massive, where it's just a big chunk and there's no contours to it. There's no pores and channels, nothing. Because when we get our compacted soils, our precipitation, it can't get through. We want to have our soil structured so that we can get it through. And the nice thing, unless if you have sands, we want to get that water to infiltrate quickly. If you have sandy soils, then the answer is organic matter. And we'll get to that one later. So while we increase our infiltration, we're protecting our soil surface because we're allowing that water to infiltrate. And with that water infiltrating, it's not going to run off and erode and take our soils and organic matter with it. We're going to reduce erosion and reduce our crop stress, because if we can get that water to infiltrate and there's enough pore space for oxygen to be there too, our plants will be nice and happy. And it reduces ponding, and you can get out there sooner. The average erosion rate in Minnesota is 5.2 tons per acre per year. And we're losing nutrients with that. Nitrogen, phosphorus, potassium, sulfur, all of that. So every time we're eroding our soils and losing it, we're actually losing money too, because then we have to pay to replace those nutrients that we just lost. and the organic matter. Oh man, I don't know. I'm pretty tight. I don't like spending my money when I don't have to. I like keeping it. So in crop fields, and I did some testing on some CSA farms this spring. So I can update this. There is a lot of them that we were lucky to get half an inch of water to infiltrate in an hour. Lucky. So if we have a nice slow rain, okay, that's good. We can handle it. But anything above that, and really that's being generous. We're not infiltrating the rest of that. It's either running off or it's ponding and then evaporating. And then our plants can't get it later. And then our average infiltration rates when we are using soil health practices, no-till, strip-till, cover crops. Yes, I focus mostly on large scale ag. Yeah. I mean, our average is like 8 inches per hour, same soil type. And I've been out on some fields where it was 24 inches per hour. We just kept dumping water and it just kept taking it. He did corn, soybeans, small grain rotation. Beautiful. No-till cover crops. Oh, gorgeous. Some of the most beautiful soils in ag production I've seen: corn, soybeans, small grains. So we can do it. All right, sorry. I'm getting a little excited about it. So if you can see on this picture too, like I moved this residue aside and that's where you'll see all that nice structure. So yeah, go out there, move some of that litter aside. Oh, and worm scat. Yes, that nice brown bulbous. That is liquid gold. That's like nutrients, plant available right then and there. And you'll find that under the residue too. Yeah, so compaction. So underserved soils, only about half of it should actually be soils, like the mineral content. 25% available for water, 25% available for air. That fluctuates depending on how saturated and dry your soils are. But about half of it should be just pore space, like your hallways, your highways and roads in your community. And then I love this. They put like 5% for organic matter. How nice would that be, right? Yeah. So in our typical compacted soils, about 3/4 of it is actually soil mineral matter. And so we're reducing our pore size down by half. And that really reduces the amount of water that we can hold on to. With our undisturbed soils, we can hold 130,000 gallons of water per acre at a 1-inch depth. That's just 1 inch. And we're cutting that in half with our compacted soils. So how does that affect our productivity? Oh, man, yeah, it really gets me. So rooting issues. So all of these are kind of like the first things that we see. Rooting issues, our infiltration isn't happening, our oxygen exchange is reduced, we're reducing our water holding, and our structure, our pores and channels are all reduced. And that leads us to less nutrient and water uptake by the plant. It's not happening, it's not there, it's not able to do it. Oh, yeah, haha, I see, I didn't update this. Less nutrient uptake, again, it's really that big of a deal. We're decreasing our populations and diversity of soil organisms, which I'll get to a little bit later why that's so important. Increasing our runoff, our drought susceptibility, delayed planting. Oh, so yes, we want our soils to warm up, so they need to dry out and warm up quickly, especially in Minnesota. So that's why we till it, because what albedo? The dark. Yeah, it's been a while since I've been to college. Darker surfaces warm up faster. And so if we have that crop residue out there or the plant residue out there, light colored, it doesn't warm up quite as quickly. But if we have that soil structure there, it lets that water infiltrate and it's not ponding there. And do your soils warm up faster with wet soils or slower with wet soils? Yes. And that's the kicker right there. So if our soil stays saturated and we can't infiltrate that water, it just takes so long for them to warm up. And then we'll get slower germination because it's colder. And we're actually losing nitrogen to the atmosphere too. We could be leaching it, it's possible, but most likely we're losing it to the atmosphere. So then our plants can't even get to it later. So how do we reduce compaction? Oh, well, plants. They are fantastic. The rooting on them, let them go to town. They can do so much while they're growing. So like a lot of our typical plants, corn, soybeans, once they get to about 200, 275 PSI, they start to struggle. The roots start to struggle to push through that. We've got cover crops that can go well beyond that. And we're not worried about how well our cover crops perform because they're not our commodity plant. So same thing with our gardens. I use them. I use them in my garden all the time. I use different kinds for different reasons. So we want to increase that root coverage. We want to increase the soil cover so that we take that energy out of the raindrops hitting it and also protect it from the sun, from the wind. We want to increase or add organic matter, reduce our tillage for sure, and stay off of wet soils. It's my biggest, stay off of wet soils. It's incredible how much we compact just even by walking on wet soils. It doesn't matter if you're 100 pounds or 300 pounds. So eat that dessert, you know, just stay off the wet soil. So how do we monitor compaction? How do we know if we have compaction out there? Well, you can get really fancy. And I was going to bring it in, but my hands were a little full, but you can get a penetrometer, and it's this rod that you push into the ground that has a gauge on it that'll tell you pounds per square inch, how much pressure it takes to push through the soil. They're about $250 and up. They used to be a little bit cheaper. You used to get them for $200, but now they're about $250 and up. Every NRCS office has one. And you can have them come out and use it, or you can ask to borrow it. So there is one available to the general public. If you don't want to get that fancy, a tile probe, that doesn't have a gauge on it, but it's the same thing. You just push a rod through the soil, or a wire flag. It won't tell you exactly what it is, you know, the resistance, but you can feel it as you go down, and you can feel when it hits, how deep it is. Really handy. You can look at your plant roots. Our plant roots, they want to go down. If you pull out some roots and they are going horizontal instead of vertical, it hit a compacted area and it's trying to find its way around it. Also, indicator weeds. There's a lot of them up here. Yeah. Pretty much, if a weed has a strong taproot, that's a good indicator that there's compaction out there. I mean, there's a few different reasons. Soils will send up whatever plants it needs to rectify itself. So what weeds are coming up tells you a huge story. Functional groups, what it needs, nutrients, compaction. That should be a whole nother like 3-hour session. It's amazing. But yeah, if you see anything with strong taproots, there's probably compaction. And it's going to happen. It's going to happen. We just want to reduce it. So how do we, develop soil structure? And I like this slide because it's when historically teaching soils, thinking about soils, it was all physical and chemical. Oh, you want to get your soil tested? We'll get you your NPK, your organic matter, your pH, and move along. There's nothing else to see here. But look at developing soil structure, the biological, all these ways that it develops soil structure biologically. That's what we didn't pay attention to. When I went to college, they didn't teach that. We didn't know about it even then. I'm not that old, so it wasn't that long ago. So we're discovering more and more. But it's just really impressive. So as the organic matter decomposes, there are different compounds that are released to help build soil structure. The exudates from plant roots, humus, fungal hyphae, fine roots, burrow lining. So like the sticky worms, as they go through their burrows, that helps develop the soil structure. Fecal pellets, all of it. And I didn't put it on here because I kind of feel like it's a little bit maybe overused, but glomalin, that's the soil glue. Some people call it glomulin, but as a Minnesotan, I have to say glomalin. So you might hear it a couple different ways, but that's the soil glues that help stick it together. And then physical, the freezing and thawing. So, you know, if we have some compaction, generally over winter, we'll have a freeze, and that'll help break it apart. Not last winter. The wetting and drying, unless if you're in totally sandy soils, that does nothing to help break it apart. And the roots penetrating the soil, that can help develop the soil structure. So there's a lot of biological, you know, processes happening. And why organic matter matters. It's everything like that, in the soil biology is like the secret to the recipe. It helps with our nutrient cycling and retention. So in soils, you know, you have your sand, silt, and clay. They're all different particle sizes, and clay is a really small particle size, and so is organic matter. And so there's a lot of surface area, a lot of areas for the nutrients to bind on and to hold on to. Then we get into our sands, those are relatively large particles, and there's not a lot of places for the nutrients to bind to that. So if we can increase our organic matter, the nutrients that are in our soils and that we add to them will bind to that better, and it won't be leached, it won't blow away or run off, and we'll be able to utilize that for our plants. Organic matter benefits our soil organisms. What do they eat? What do our soil organisms eat? You guys know what's on the menu each day for them? Of course, they're all a little bit different. They each, you know, there's different functional groups. We have our shredders, our bacteria, our protozoa. Some of them eat each other. Yeah. Can you imagine if you were shrunk down to their size? Terrifying. They are, if you look at pictures of them under the microscope, oh man. But they do a lot of hard work, so they're great. But a lot of them eat the residue and the plant matter, and they break that down and break that down and break that down. And so it's food for them. It improves the water holding and the water infiltration. So especially if you have sandy soils, organic matter, that's how you can hold on to your water. You have really heavy clay soils, you get your organic matter to help build your soil structure, it will infiltrate. And it helps improve our soil structure because it brings everybody to the table to build that soil structure, to make it happen. It actually even helps balance your pH. Isn't that lovely? Isn't that wonderful? Unless if you're growing blueberries, but otherwise, yes, I want a balanced pH, or you want, you know, blue flowers on your hydrangeas or whatever, you know, yeah. And it helps reduce erosion because we're infiltrating and we're holding on to our water. So even more important, well, for me, because I like getting multiple uses out of things, 1% of organic matter can provide up to 20 pounds of nitrogen per year that's plant available. So right off the top, 20 pounds of nitrogen is there ready for your plants. 5.5 pounds of phosphorus per year that's plant available, 2.5 pounds of sulfur per year that's plant available. You don't get free sulfur from the rain anymore. We fixed that problem, but now we're having to add it. So 1% of organic matter can provide that amount of nutrients per year in Minnesota. Down south, it can have more, lucky them. But this is what we can expect. So if we can increase organic matter, we can reduce the amount of fertilizer that we need to put on, or amendments. Plus, 1% of organic matter can hold 16,500 gallons of plant available water. Being able to hold all that plant available water, so if our weather is changing, and it seems to have been, hopefully we'll get out of El Nino and go back into El Nino. But we're able to hold on to 16,500 gallons of plant available water per acre with 1% of organic matter. So if we can increase organic matter we're increasing all of the nutrients and the water that we're able to hold. So how do we do that? We can bring things in, we can compost, we can do things like that. But really, the whole idea is to harvest the carbon from the air and get it into your soils. And that's going to be growing plants. And the biggest thing, we're going to have it above ground, but really it's the rooting area that makes a big difference. So if we think about the prairie soils versus the forest soils, yeah, we're in the forested soils. So typically we don't have a high organic matter amount, and we don't have those deep, dark, topsoils. And that's because with the trees, they have large roots, but they're not everywhere in the soil. And they drop their leaves annually. They don't have the roots die off annually, but in the prairies, a portion of their roots die off every year. And that's what helps contribute to that building of organic matter. So if we have those plants in the ground, and a lot of times, depending on what species you're growing, you say, because we had a lot of producers use cover crops this year, cereal rye, and they said, Jen, the plants are only like 6 inches, on top. What good is that going to do? It's like, well, lots of things. But I really wanted to tell them about the underground. So we dug some of them up, and the roots were twice as long as the above ground growth. And so that's carbon right into your soil, which you can't hurt putting that in there. And another thing I like looking at, there's so many things to talk about with soils. It's really hard to like mush this down. So hopefully I don't leave anything out, but we can always ask questions too. The carbon to nitrogen ratio. This essentially binds up nitrogen, or it lets nitrogen free flow. We want to look at they say like 20 to 1, 24 to 1 is the optimal range for having nutrients become available. If we have a higher carbon to nitrogen ratio, so we put a lot of, wood chips out there. Oh, well, now our plants aren't going to have enough nitrogen because the carbon to nitrogen ratio will be off, and those wood chips will tie up that nitrogen. But if all we put out there is green matter, green, young, we're going to have a flush of nitrogen that isn't going to be able to be used in the right time or quickly enough. And it will go to waste. And so if we want to look at using some different cover crop species, some of them like sorghum Sudan grass that has a really high carbon to nitrogen ratio that'll tie up the nitrogen. But then we've got like our legumes, our peas, our clovers has a low carbon to nitrogen ratio, and that nitrogen is free flowing. Kind of like if you guys compost, you totally get this. This is on your mind all the time. And so we can utilize this during the year. Are there times that we want to lock up that nitrogen after harvest into the winter, into the spring? Early spring is a critical period from March to the end of May. We're actually in it, although there's really not much rain to speak of, but that's when we lose the majority of our nitrogen, or the nitrates, to the ground. And so that's when we want to have that locked up and protected, because then as that residue decomposes, it'll release it back into the soil. So it's kind of neat. We can play with that to either lock it up or let it free flow. So we want to think about, what tillage type you're doing, what crops are grown. If you're going to use cover crops, for the amount of residue that's going to be out there. Do you want a long lasting residue, or do you want it to decompose really quickly? What are your crop needs? Do your crops need a lot of nitrogen, and at what stages do they need it? Do you want to build organic matter? If you want to build organic matter, you don't want your carbon to nitrogen ratio too low, otherwise it'll just burn it all up. With some of our fields that were no-tilling and putting cover crops in, by July, there's no residue out there anymore. It all went away. Why is that? Because we got our soils to function, and our soil organisms are out there eating all of that residue and decomposing it. So as you increase your soil health, you'll find you'll have that problem where you don't have enough residue doing what you used to do. It's all a change. Everything, changes as things go. So don't be surprised if, and that happened on our farm last year. Oh, I'm like, we don't have enough residue. We need more cover crops. Yes. So to improve the nutrient cycling, organic matter, but you can't overdo it like with compost. So just know that there are other ways to increase organic matter besides compost. Reduce tillage. We want to reduce our compaction, build our soil structure, use nutrient management. I hope everyone's soil testing. Excellent, very important. Use plant diversity and look into that carbon to nitrogen ratio, because we can actually lock up different kinds of nutrients depending on our carbon to nitrogen ratio. And benefits of soil biology. Oh, yes. Okay, so we thought organic matter was interesting. That was just like the gateway into the real stuff. Okay, so soil biology, that's what makes it all happen. We can reduce our input costs of fertilizer, pesticides, our need for tillage. The Dakota Lakes Research Farm in South Dakota, they've been doing soil health practices for years. And out on one of their cornfields, they put armyworms out there, and they put them out past the population density where if you would find them, you would spray. They put them out there to see what would happen. They didn't have any yield loss. How? Everybody else, if they were to go out and scout their fields and find that population of armyworms, they would spray because it would be decimated. Because they had soil biology out there and they had enough of a population and a diverse population to help battle them off. Yeah. And if we really want to get nerdy, we could talk about taking Brix readings, because typically pests only go after plants that aren't in the ideal state of health as well. Kind of like people. People can be bit by ticks and have Lyme disease in them, but they're fine. They're fine until something else gets them down. Same thing with plants. So we need our soil organisms there as our immune system. They can also help do pollution prevention because they are cycling things. They're holding on to things. They're not just letting all the nutrients, all the sprays go leach down or erode off. Improving our crop quality and yield because they're helping to improve our soil structure, our water holding and infiltration, our nutrient cycling and availability, battling those pests and disease, and forming those symbiotic relationships. So, all right, we're talking about soils and soil organisms. Why is there a dinner bell? We've all probably tried some weird things in our lives for food, but I don't know. Worms are not high on my list. I know I've accidentally eaten some before. Yeah, whatever. We've done it. I'm not proud. But really with soil biology, they have evolved living with plants for thousands and thousands of years. They figured out how to work together, how to get along. And so when plants are growing in the soil, they utilize their energy to exude different compounds through their roots into the soil. So they're making sugars, they're making carbohydrates, proteins, all depending on what they need. Why would the plants waste their precious energy to then just exude these compounds into the soil? What are they going to get out of it? They are ringing the dinner bell. They are saying, hey, I'm here, come and help me, come and get it. Because what happens, it's their form of communication. They don't talk like we do. So they exude different compounds depending on what they need, because that will attract certain soil organisms to help provide them what they need at that point. And so if you have a good population and diversity of soil organisms, that plant doesn't have to waste a lot of energy exuding those compounds. They'll start exuding them. Those critters will come and they'll take care of whatever the deal is. But if we're lacking our soil biology and we don't have a good population or diversity, that plant will keep exuding those compounds and wasting his energy, but asking like, where are you guys? I need you. Come help. So it is just really neat. It's a huge rabbit hole to go down to, but yes, they help each other out. They provide plants with nutrients, cycling the nutrients to make them plant available, creating various stages of organic matter. So we don't want all of our organic matter to cycle right away, because then it's gone. We want multiple stages of carbonaceous material in our soil, some that will essentially never break down, are medium length where it's like, yeah, it'll be there for 10 years or so, and then the residue that it'll break down and become plant available right away. We need all those stages in the soil organisms. They're the ones that do it. And then create the relationships with the plants to extend the rooting area and exchange the nutrients, air, and water with plants. They make it all happen. And it's like our digestive system. I love pizza. I love pizza so much. I think I had too much of it last winter. So if I just eat a bunch of pizza, but I take my multivitamin, am I going to be healthy? Like, is that a functioning system? No. And if we treat our soils that way, it'll be the same kind of setup. We need that diversity. They are essentially the immune system of our soils. And I have a lot of people asking about biologicals. Should they add them to their soils? Are they worth it? Well, that's up to you. A lot of them, when you add them, they don't stick around. You have to keep adding them. And it's kind of like, all right, so now beyond our vitamin, we're taking some other supplement. Well, we're still just eating pizza. Is that really going to do it? Because if we're causing the behavior for those soil organisms to not be there, we're spending a lot of money adding them, but we're not providing them the environment for them to flourish. So just something to think about, like compost teas, things like that. I mean, that's fantastic. But the bug in the jug, just be really careful, because we can create a system and a community for them where we don't have to purchase that and add it, and we can keep them there. So we want to be able to create that environment for them. The balance matters. Typically in our corn soybean rotations, we have high bacteria, low fungus populations. And that's not good, because bacteria, they really eat up that carbon. And that's why we're losing our soil organic matter, besides erosion. So we need to have a good balance. And I mean, that topsoil is alive. I don't know, you guys probably heard it. I don't know. I talk about soils a lot, so I don't want to say old things that people know, but in a tablespoon of soil, there are more living organisms in it than there are people on the earth. Isn't that nuts? This is nuts. And then we just treat it like dirt. All those poor little critters, man. So want to think about how we can make it hospitable for them, because then we can do less work too. And you can either call me lazy or you can call me efficient. Either way, I don't like doing things I don't have to do. So when we're improving our soil biology, all right, and this might be triggering for people too. Some people say like, oh, aren't worms bad? Well, jumping worms are horrible. Yes. In a forest system, yes, worms are bad. In our gardens, in agriculture, they're fantastic. They do the tillage for you for free. You just feed them. You just leave some of your plant matter out there. They're fed. They're happy. So in food systems, ag, horticulture, they're good. Not in forests. So we want to increase our soil organic matter and our surface residue. That way they can build their homes, they have things to eat, they have protection, We want to reduce our tillage so that we're not bringing the tornado through their community all the time, reducing the compaction so they can actually get somewhere. The water and air can circulate, increase our roots, our living plants, increase diversity, use nutrient pest management, utilize manure, but be careful where you get your manure from, because there could be weed seeds in there. And if you get horse manure, horses do not break down herbicides in their digestive system. So if they eat feed with herbicide in it, it's going to come out the other end too. An organic farmer found that out the hard way. Oh, yeah, I didn't know that either. That's detrimental. So, but I don't know if you guys noticed, but I kind of sound like a broken record. I'm saying a lot of the same things over and over again that are good for all these different things, like keeping your soil covered, reducing disturbance, increase diversity, and keep a living root. Those are actually the soil health principles. And I don't like making that so apparent. I like giving like the background, to make it stick, because if you just, say 4 rules, well, rules are made to be broken, right? So we'll just try to understand what they mean. But yeah, manure can be fantastic, but then watch out if you're using too much manure, then your phosphorus is going to be too high. And then you're going to have issues with other nutrients, things like that. Oh yeah, and too high of phosphorus, you won't have as much mycorrhizal fungi either. And if your magnesium is too high, your soils won't want to aggregate. They'll split apart. So if you're going to lime, use a calcium-based lime. So benefits of soil health practices. I broke a rule. They say, oh, don't put too many things on a slide. Well, I did it for a reason, because these are the benefits of soil health practices plus more. But it's, it's going to help our plants. We're going to reduce our erosion, increase our organic matter, the nutrient cycling, the infiltration, the water holding, the reducing compaction, pest management, profitability, weed control, and what I really like, the handling of extreme temperature and precip. Welcome to Minnesota, everybody, right? What was it? 2 months ago, a month and a half ago, and it's been hot. Yeah, so we want to be able to handle the extreme temperature ranges and precipitation. We had so much snow this winter and now nothing. So we want to be able to handle that. So there's some tools out there. You can use cover crops, reduce till, stay off of wet soils. My poor kids, they should have made me a hat or a shirt that said stay off the lawn when it's wet. Organic amendments, nutrient management, integrated pest management, which is really, really fantastic. If we look at it in a holistic approach, we can really, really, provide benefits beyond just buying, something quick and easy. Integrating livestock, and if you can't integrate livestock, integrate their manure if possible, but be careful. So what do we do with this information? I'm probably going way over.
You got 8 minutes.
8 minutes, all right.
Without questions.
Oh,
So-
no, I'm sorry. Gosh, see? I'm talking about soil. All right. So you want to assess your goals. Yeah. I'm assuming we want high yielding plant production and plant health, balance our nutrients. And so step 1, test your soil. We don't know what to do with it if we don't test it. You can't monitor it. You can't do anything. It's just a guess. Go ahead and test. I just made that up. Okay, awesome. So to get the high yielding production, we need all ducks in a row. Understand your vegetation requirements, optimize your nutrient balance, correct your pH. That can make or break you. Get your soil structure there. C to N ratio had, 8-to-1, 15-to-1 when we're really moving. Otherwise, 24-to-1 is just fine too. Pest disease management. Increase infiltration, add compost, add things, residue to the top, add your amendments, convert to no-till. What we want to do, we want to build up our soils and then if possible, reduce disturbance, try to do no-till. Obviously, if we're doing potatoes, that's, you just can't. I always feel bad when I still grow potatoes. Reduce sources of compaction, including foot traffic, utilize cover or companion crops. If your soils are high in clay, do not add sand. Do not. And if your soils are sandy, do not add clay. You will create cement. So it doesn't quite work to try to balance it that way. I'm gonna throw that one in there. If we want to increase soil organic matter, add carbon sources, and then keep it, try to, 24:1. That'll make it so it doesn't burn off too quickly. Reduce disturbance, compost manure, leave residue over winter, also good for pollinators. Add mulch to the surface, cover crops, companion crops. All of this is kind of the same stuff over and over again, because it's the magic. And how you do it, it will differ. Everyone's system is different. Every patch, every field is going to be different, but it's the same thing. Organic matter, reduced disturbance, living roots. Soil tests every 3 to 4 years or more often, especially in vegetable production. Understand how fast your amendment releases, because it might be gone before you know it. pH, and watch for high and very high nutrients because that will muck up the other ones. Use magnesium base, smaller particle sizes, faster acting. Soil life, work with plants, make them available. Living soils warm up faster because they are not saturated. Provide a home, don't destroy it, give them a roof, living roots, reduce disturbance.